All right, let's get some answers to this dealing decks of cards from the beginning of the universe quiz. So Firefox has been acting up today, so I'm going to use Chrome, and hopefully that works better. Okay, so let's see. Oh, yep, there's the age of the universe. I Googled it last time when I was making the quiz. 13.7 billion years from NASA. Let's see what Wikipedia says, which probably points to the same link. Let me just see. In 2018, Planck collaboration. That's a publication in astronomy and astrophysics. I'm tempted to believe that. And they're saying the same thing. 13.787 plus or minus 0.02. So yeah, let's call it 14 billion years. That's what it seems to be. The first couple hits that are in peer-reviewed sources. Convert that time, which is in years, billion years, to seconds by multiplying by those four numbers. Okay, so I'm going to use Chrome again because Chrome was working pretty well. So we had 14 billion, 1,000, million, billion, there we go, times 365.24 times 24 times 60 times 60. So that's going to be that number right there, 4.4 times 10 to the 17th. That's how many seconds old the universe is. And in number 3 here, explain why those numbers converted years to seconds. So the first one here, 365.24, that's how many days there are in a year. The 0.24 is kind of fun because that's one of the reasons, A, you have leap years, and B, every 100 years you don't have a leap year. So that first factor is changing years to days. The next factor is changing days to hours because there are 24 hours per one day. Now you're in hours. There are 60 minutes in an hour, so that's where the next 60 comes from. The last 60 is 60 seconds in a minute. So multiplying by all that converts years into seconds. Yay! All right. Now I walk you through some estimation. I showed you a video here if you wanted to watch it. And I said, we have to figure out how many billion decks or how many decks of cards there are in the world. So I said, all right. I did some quick Fermi math, named after Enrico Fermi, a famous physicist from the Manhattan Project years. And I took some liberties with multiplications of factors that I saw in the video. And I said, okay, it's about 41 billion decks of cards. So then I made it that much worse, 50 trillion. I just said, to hell with it. Let's just make it as ridiculous a number as possible to overestimate how many decks of cards there are on Earth. I just need a number to work with to compare to the number 52 factorial. Okay, so I now say that all those 50 trillion cards, which is a gross overestimate, were also around at the beginning of the universe, which is ridiculous because nothing was around at the beginning of the universe except for, well, nothing. So I also said, since we're in the realm of possibility here, let's also put a person with each of those decks of cards, so they're able to shuffle them. To further the ridiculousness, let's assume that all 50 trillion of those people are able to shuffle their decks once per second. Which actually, the fact that 50 trillion people were there at the beginning of the universe is ridiculous. But shuffling a deck of cards once per second isn't crazy. I mean, it probably takes me 2 or 3 seconds to shuffle them. But let's say that they can do it once per second. How many actual shuffles, I called them deals here, I probably should have called them shuffles, but how many deals would happen if they shuffled their decks once per second over the length of time? So I told you to show me what you did here, but don't overthink it. If you can get 50 trillion shuffles per second, and you've got this many seconds in the universe, all you've got to do is multiply this number by 50 trillion. That's how many shuffles would happen if 50 trillion people shuffled once per second from the beginning of the universe. 2.2 times 10 to the 31st power. So imagine moving that decimal point between the twos 31 places to the right. However, I want you to compare that by using multiplication. And I don't know why I called that 6a. That's number 4, not 6a. How many times less is that number than the value of 52 factorial? So what I want to do is I want to take 52 factorial, which I know is equal to which I know is equal to this number here. I'm going to copy this one. And I'm going to divide that number 52 factorial. I'm going to have to write it. 8.1 times 10 to the 67th divided by this monster number here. And that is how many times less it is. Now, I told you I didn't want you to write any zeros. So now what I'm going to do is I'm going to use one of my favorite tools, the Big Number Calculator. This is one of my favorite tools. I'm going to redo all these numbers with their full decimal places. So 52 factorial is that number right there. I'm going to take that number and I'm going to copy it into a new Chrome window. Whoops. What am I doing here? Copy. Just copy the number, please. There you go. Copy. Okay, so I'm going to take that number. I'm going to copy it over here. All right. Now, I also have to get the other numbers that I've used in this quiz so far. So I got to use 14 billion times all this stuff here. So first thing I want to do is, some of this I can do without the Big Number Calculator. I'm going to put a new window here. I'm going to do 365.24 times 24 times 60 times 60. That gets me, that's the number that I multiplied by what was it? It was number 2. So that's how many seconds there are in a year. So I'm going to multiply that. I'm going to put that in the Big Number Calculator. And I'm going to multiply that by 14 billion. Thousand, million, billion. Okay, multiply. All right, so that's that number. Now I got to take that number and multiply that by 50 trillion. I'm trying to copy, there we go. Copy that, put that in there, and 50 trillion. Okay, so 50. Thousand, million, billion, trillion. Multiply. All right, so that's that number you got in number 4. So I'm going to take that, and I'm going to divide 52 factorial by that number. Yep, it still gives it to us in scientific notation, but I can also put that number back into my Big Number Calculator, which I don't know why I didn't do that in the first place. That was kind of silly. I apologize, y'all. So I'm going to put this number here, and I'm going to put the 52 factorial part of it in the top. You're watching what happens when Sean doesn't get enough coffee in the morning. So there's 52 factorial. There's 50 trillion times the age of the universe in seconds. Divide them. Where's division? There it is. And that is the number you see in Google. So that is the solution to the last question I just asked you. That's how many times less all those deals are than 52 factorial. Now, is it possible that you got a match somewhere? Of course it's possible. Is it probable? No, not really at all. Because that number is so massive, it's more likely that you got a unique shuffle. Now, if you want to go further than that, I'm not going to make another quiz. Maybe I'll put it on your exam. I'll see. But if you want to dive deeper into this world of big numbers, feel free to send me an email, and I'll talk you through it. Be well.